Any suggestions of how to figure out what do you do? I mean, let's say if you are not in class, you are doing your homework, and you see something like that. What would you suggest? What would you do? What do you look at to figure out what happened?
Plot the approximation over the real curve.
Yes. Can I look at the solution history, right? I mean, this is the end of the trajectory, right? I mean, remember, we have been trying to prove Euler's formula, right? I mean, if you let me just run forward Euler again, right? Let me just run, for example, the forward Euler, a scheme that we know works. And we can plot the U. Remember, let's make another figure. Remember, we have actually saved all the history, right? I mean, so this is actually a solution, a numerical solution in a complex space. Here, I think x is equal should work, hopefully. Yeah, so basically, we can see that we started with 1. And I mean, this actually explains what happens in Euler's formula, why there is a pi there, right? The solution actually follows a curve, right, that goes over. It's like it's exactly like a semicircle. That's why you need to integrate over pi to actually get to -1, right? That's the connection between the geometrical nature of pi and the calculus nature of E, right? Okay, so that's a forward Euler solution. But how about a third order solution? So let's actually run this one, and let's figure and plot U. Well, it's not very helpful, right? We don't know what's going on. So I mean, U is a huge array. Remember, we are using the finest calculation here, right? So U is going to be a huge array. So why don't we actually just plot the first few instances of U? So from 1 to, let's say, 10. And I'm going to just in order to see visually which one it is, I'm going to use a O. Interesting, right? So what am I supposed to do, right? Remember, I want to complete a semicircle. That's the real solution, okay? So it is doing the right thing. It's going up. And it's actually slightly curving to the left, which is correct, right? But then it starts to do this. It's kind of deviating from the left. I mean, you can see it deviating left a little bit. Then it tries to correct. Then it corrects too much, right? Then you want to kind of go left and to the right. It's almost like you are over-correcting. If you are, it's almost like you are driving or something. You are over-correcting and you're just going crazy like that. This is a stability problem, right? And so what's causing this? I mean, is there a way we can look at the formula and figure out, oh, is it like forward Euler that's stable, that's actually going to complete my semicircle? Or is it going to be a scheme like that that's going to go wild really since the very beginning, right, after a few steps? Oh, if you plot a little bit more, it's going to be doing the same thing, except for it's a little bit more crazy. And if you plot 1,000 steps, where am I? Oh, it's already gone. Okay, yeah, it's already let's say, because this thing actually blows up exponentially, right? Wow, even 100 steps, yeah, even 100 steps is going to go up to 10 to the 32, I guess. You see, 10 steps, you're still 10 to the -3, right? And 20 steps, wow, you are on the order 1, right? The oscillation is already overwhelming the solution itself. 30 steps, you are on 10 to the 4 already. So it looks like every step you are blowing up in order of magnitude. The 40 steps, you are 10 to the 6. So there is no hope. You are basically blowing up.